So we are going to learn about introduction of Spark and evolution and history behind Spark and ubiquitous and unified big data processing platform, which is Spark. So we are going to learn here is getting after the complete this course you are going to learn about getting started with the Spark and history of Spark, why we need a Spark, and differences with the traditional MapReduce, and where we can use Spark, and I will provide the GitHub links. So let's start with the getting started with the Spark intro. Spark has become a ubiquitous platform for data processing and has taken over the traditional MapReduce fact. So in fact, some of technology company would go far as declare MapReduce is already dead. So Spark has been proven and outperform for MapReduce several order of magnitudes and numerous benchmark and performance studies. Below, we are briefly recount the history and behind Spark dominance in the big data space. So, what is the history behind the Sparks? We are going to learn here. So, the big data movement is earnest of Google ambitions of index of World Wide Web and make searchable for user to lightning speeds. So the Google search engines, they use some index concepts, and it's increase the speed of searching algorithm. So behind this there was three things. First was the Google file system, and then second was the big table and the MapReduce. So Google file system, or which we now it's similar to the Hadoop file system. So it is fault tolerance distributed file system running on cluster of cheap commodity hardware. So there are many computers, they are connected each others. That means it's and fault tolerance means they keep copy of each data into three computer with is different reasons. So there is a separate topic you can learn about GFS, what's the behind. And then the big table, so it's a scalable stored structured data on top of GFS. So big table is on top of GFS, scalable structured data, and then they use MapReduce to read data from big table. So it was a new parallel programming paradigm that allow processing large amount of data distributed across GFS and big table. So this was the processing. So the history, the continuous part here. So in the MapReduce, what they read data from GFS or SDFS and put the data into again another disk, again the same process, read and put again the hard disk. So MapReduce read data and put into hard disk. So let's go into the deep. Google's work was probably what's paper is coming on the efforts. So in Hadoop, the open source implementation of the Google's ideas by Yahoo engineer. Hadoop project was later donated to Apache. Although MapReduce worked well for batch processing, it is some complex. It has steep learning curve and take long time. The weakness of MapReduce is that write intermediate result into disk, which I told before, which slow down the overall computation. And consider the scenario where MapReduce jobs output fed to second jobs as an input. The first job dumped output data into disk upon completion, then the second job reads input again the disk, the IO again the disk, slow down the overall processing power. The shortcomings, the problem of this MapReduce didn't go down unnoticed. The Spark was started as a project. So the problem of the MapReduce, solving the MapReduce problem, Spark is started. 29 University at California Berkeley with research paper of finding published in follow year. Later the same folks created company called the Databricks. You can go in that these links I will provide in my video. And Spark paper, which is focused on Spark based machine learning and analytics solution. Spark has become a de facto platform for data processing for a wide variety of use cases, ranging from batch processing to interactive ad hoc query for real-time analytics. Scala is a default language for Spark. However, Spark also works with Python, Java, and R. So now the next part we are going difference with MapReduce. So if you see in this image, first one is MapReduce processing and second is Spark processing. In MapReduce, as I said before, disk read, and MapReduce is iteration, disk write again, then those data read next MapReduce and write. Okay, but in Spark there is many read data from disk iteration, then store data into memory. From that memory the next iteration will take and put into memory, then it write back to the disk. So that only the difference here you can see there, MapReduce we write back to disk, here they keep in memory. So we go into details MapReduce difference. So what is that Spark does better than MapReduce? Let the big data community abandon MapReduce. The answer is the question. We will look at the case of MapReduce paradigm is false source. So first part is interactive jobs, then interactive analysis, then rich API. So certain machine learning algorithm, if you know multiple pass on the data sets and compute the result, each pass can express as a distinct MapReduce jobs, and consequences is that each job read input data from disk and then dump output. So if you know about machine learning basically work with the interactive input. So one output go to another go to the it's a kind of the loops. So first will complete, then second sum. So MapReduce, what it will happen, it will put into a disk. So that's where the MapReduce got failed. It take a lot of time. Second point is interactive analysis. User can run ad hoc SQL queries on the large dataset using tools such as Hive or Pig. If user issues the multiple queries targeting the same datasets, it's possible that each query under hood translate to MapReduce jobs and read the same dataset from disk and operate on it. Multiple MapReduce job reading the same dataset from disk is efficient and increase the query execution time or latency, which increased latency means it take a lot of time. So where the MapReduce got failed. And the third point is with the feature of the Spark, we can say Spark offer variety of rich API that can successfully express an operation that would otherwise consist of dozen of lines code of when the express of MapReduce. The Spark have rich API, which you can write same code you need to write MapReduce lot of dozen of code, but Spark you can write in the the one line because they have a lot of APIs. The user and developer express the simpler when working with the Spark versus MapReduce. So if you see the original first and two, interactive job, interactive analyze, this was originally written in the paper of Spark, and so this lead to design alternative data parallel processing framework other than MapReduce. Spark retain much of the features of MapReduce such as fault tolerance, locality aware scheduling, load balancing, while efficient reusing data caching in the memory cluster. The previous costly round trip disk memory access is always faster than disk access, which explain much in Spark superiority over the MapReduce. So now the next part I'm going to is a very important parts for you guys. So where we use the Spark, what is the use cases of Spark? So first one, I'm working as a data engineer, so it's come in my mind for parallel processing of large data sets across the cluster. So if you have large data sets and you want to do parallel processing, then the Spark is the right choice. And analyzing large data sets and social network. So large data set also you want to find hidden information, then Spark is a good choice. And building and training and evaluating some machine learning models, Spark is very good choice because previously I worked one of the machine learning, same I use MapReduce program or SQL. It took for me 24 hours, but when I convert into Spark, it complete within 30 minutes. So Spark is very powerful for machine learning. Creating data pipeline from various data sources is also the use cases. And now this is architecture, but I'm not going in detail. In the coming lecture I'm going to go into details, but you can see Spark core and Spark SQL engine. It supports Scala, SQL, Python, Java, and R. On top of that, Spark SQL, Spark streaming and machine learning, and then graph processing, GraphX, which we call. So I will provide a link. This is a GitHub link of the Spark. I will provide in my lecture, and this is a Spark original document. So you guys please download Spark and start working on this one. So there are a lot of companies, they are using Spark, so it's very important if you really want to learn about data processing or big data. So please subscribe my channel, like my channel, so I can create the knowledgeable video for you guys. Thank you for watching.